All right, the recording button is about to be set. No, sir, this is a free webinar meeting, so therefore there is no PDF for this. But you will be having access to the recording. So welcome to the Align Power sponsor Duramax L5P Diagnostic Tips. Yes, this recording will be available to be viewed later on, so you should see a login or a link in your emails in the future. So therefore, yeah. Now, let me get one thing clear. If you know me as Tony Salas and you've attended my training, let's get one thing clear. If you're one of those people that wants to learn everything in an hour and a half or an hour webinar, no. Okay, this is a tips. Let's get this thing clear. Tips. So if you want to know everything you want to know about L5P, no, this is not going to work. That's why we have training. That's why there's training classes and so on. So yeah, I don't cut to the, I don't want to say bad words, but I don't want to act like, I'm going to give you everything you need to know about L5P. So therefore, yeah, you should be taking training. I know some of you are struggling, but we do have on-demand classes on my website as well. But in this case, yeah, we stress the need to have classes. As a matter of fact, you'll see me talk about some Alliant Power classes that they're hosting at different locations. One of them is coming up is in PA, Lebanon, Pennsylvania, at Zimi's Diesel. We'll talk about that later. But anyways, definitely want to make you understand that you're going to learn a little bit about tips. So welcome to the Align Power Duramax L5P Diagnostic Tips. My name once again is Tony Salas. We're going to talk about it, but so let's get into it because time is of essence here. So therefore, hopefully this will help you. Let's get this thing PowerPoint going here. We're happy you're here, but whether you are, where are you with current technology? Okay, bottom line, current technology. Like I said already, if you're going to learn everything you need to learn, no, we need to make investments in training. And believe me, yes, I am a training provider, but I also do I got a little shop here that I do work to as well. As a matter of fact, I got a Power Stroke 6.7 and go try to get the turbo out and do an exhaust leak fix, which is not going to be a lot of fun. So therefore, yeah, I do that stuff too. So therefore, Tony does wrench as well. But the thing is, where are you with current technology? I mean, you got finally a grasp on this after treatment? I mean, what's going on with after treatment? And what I mean by that is, do you know it? Do you understand it? I mean, do you know what's causing DPF loading? Do you understand SCR, how to resets, and so on? So, yeah, we need to make sure you have a basic understanding of that because even when I teach my classes, I'm in awe of some of the guys that come to my class because they don't know. I mean, I'm happy you're glad you're in class, but the problem is that, we have no understanding yet of after treatment. In other words, when the DEF fluid is injected, do you understand that it turns into what? Let's see, DEF fluid is 32.5% solution of urea with water. And when is that injected with the heat in the exhaust, the chemical reaction creates what? Ammonia. So therefore, it is the ammonia that breaks up the NOx. And some guys have no clue about all this and why it does what it does because, things are changing. And I'm going to hit on something here real quickly as I move along here. But then there comes co-diagnosis. Do you follow a diagnostic plan? So therefore, I could teach you everything you want me to teach you. But once again, if that attitude sucks of yours and you're not following a structured diagnostic plan, then you're not going to be, you're always going to be shooting it from the hip, like I've always said. So service manual, you got access to good service information. Can you read the information? Can you find the diagrams, especially in a timely manner? And electrical, oh God, the electrical thing, it's been a never ending thing with electrical that I keep talking about. Where are you at? Voltage drop testing, using meters and so on, including your scan tool and your multimeter. So therefore, yeah, you should be actually, in other words, you need to understand what's going on and what you're reading and know the full capabilities of your multimeter and your scan tool as well. So, yeah, I mean, come on, guys, you got to get up to speed. We're running out of people in this industry. We're having struggles, but there are businesses that have very sharp technicians that I visit, and they know their stuff because they invest heavily into their training, whether with me or anybody else. I don't care. What I'm saying is get trained, if you don't understand this, especially on the electrical side of things. So diagnosis, I've stated before on a previous L5P, is, it starts with the planned diagnostic approach. I know some of you guys have heard this and bear with me here for a bit, but in this case, the basics in visual inspection, the air filter, checking everything that you're supposed to check because, like I've said before, if you got an L5P or you got any truck diesel that's coming in and it's got a issue, the question is, how did that issue affect the after treatment? I hate the truck that comes in with a blown motor, and when that blown motor is there, it's like you don't know how it affected the after treatment, such as, the head gaskets and failure. So when you look at the L5P, the L5P itself, some of you have been working on them, and 2017 was the introduction of this engine, and it is a very common, from the LB7 to the LMM, to the LML. You see the L5P, and the L5P, what's the biggest change we see? Well, the turbo arrangement is different, but also the common rail injection system is different, which is the Denso, which some of us have struggled because if you know your LMLs, you know that they were using the Bosch Piezo common rail with the CP4, while here with the Denso, we see the use of the Denso common rail system, which is solenoid style, okay, solenoid style injector. So we've had a few issues. So the one thing I'm going to throw at you that I'm going to mention again, because if you know how I teach, I repeat things. And in this case, one of the things is you may want to start looking at your misfire counters. Look at your misfire counters. So yes, so therefore I was working with one guy and then I was working with three other shops talking about this and looking at misfire counters when we're having issues with injector quantity and quality test. I've reached out to Alliant Power. They're still working on getting me some information on the struggles they're having in testing this common rail injector, but we'll get more into that. But before we even continue even talking about anything about drivability in the common rail system is, let's face it, guys, when I get new diesel owners and this is their first diesel, the thing that I often tell them is diesel fuel is not consistent. Since I deal with a lot of you all over the country, we don't have consistency in diesel fuel. Here in Las Vegas, where I'm home based out of, yes, I'm home based out of Las Vegas, it's like, what is the quality of fuel, because our fuel is not consistent also as well. So therefore, fuel is another issue of what can cause issues with the common rail system. And if you've seen me ever talk about common rail, I've always mentioned what is always the number one enemy of common rail has been always contamination. So therefore, contamination is your big problem. So yeah, these motors are they can be okay, they cannot be okay, depending on how you want to look at it. But in this case, numerous failures can occur, but it all comes down to the maintenance, as some of you already know. So let's get right into this. So as you know, a brief look of the introduction of the 2017 model. We did have a change dramatically because, like I said, common rail, the turbo, everything was varied between the LML. And you're going to find out when you look at service information that a lot of service information, it seemed like General Motors copy and pasted LML stuff into the L5P, and there were differences between them. So therefore, be aware that when you look at the service manual. Now, when I talk about service manual, yes, I've used your all datas, your pro demands, and the identifics, the big three that everybody knows mostly of. And in this case, the problem that I've seen is that I tend to like to use Identifix. And the reason why is because they're taking you straight to the GM website. So you're working as if you were logged into the GM server. So you are seeing genuine GM service information. Now, if I compare this, like I will talk tomorrow about Ford, you're going to find that GM is a little bit laggy on when you see the comparisons of service manual structure that you see with Ford versus GM, so. And Ram Dodge, well, that's another thing. We'll talk about that another time. But in this case, VIN code Y, displacement 6.6 liters. So yeah, you see a lot of carryover all the way from the previous LML. Now, the one thing for some of you that have not seen a presentation on the L5P is that, we're hitting 29,000 PSI with solenoid injectors up to 7 injection combustion sequence. Now, as I will talk about later with Common Rail, and some of you already have heard this, but some of you have not heard my modified version of this, is that what is the biggest difference that we're going to see with today's Common Rail that General Motors has done in their software is that you deliver fuel. But when you deliver fuel through the injector, it's under the understanding that everything is in perfect mode. And that's the one thing we've had to learn in dealing with these real, I call them weird codes. And what I call them, they're so weird and testy because they require a certain condition. For example, when I'm talking about injector quantity and quality codes, you're going to find out that some of them require for you to run the test to see if that code repeats itself is a deceleration event. But the other thing you're going to realize is that the mass airflow, along with the map sensor, is a key element along with the condition of the after treatment. So as you move air through an engine, yes, air goes through the air filter, through the intake, it gets boosted. And then at that point, we create our power, and then we got our exhaust. That's all one big flow, and as that flows, if that flow is interrupted in one way or another, whether being a restricted exhaust system, or we got carbon accumulation in the intake, or something as frivolous as a map sensor with accumulated carbon, as I will mention, that affects the overall judgment of how well that injector fired. So you can't just say, oh, I got an injector quality, injector quantity code, or timing code. And you're like, it's injector. You can't think that way. Sorry, you can't think that way. Now, I know some of you are saying, well, I got balancing rates. Are there balancing rates still like we used to use on the old Duramaxes from LB7 all the way to the LMLs? Yes, but it is a more finite diagnostic, so it wants to know what exactly that injector is doing, because you're going to get, for those of you who haven't been exposed to this, you're lucky. You're going to get a truck that's going to come in with a injector quantity timing code, and the truck's going to run great, but it just sets that code. That's it. That's your only code. And you're like, and you're just trying to say, well, it seems to be working okay. So we'll get more into that later. But in this case, though, the one thing I've always been saying about Duramaxes is always has been valve adjustment or valve lash adjustment. So as we talk about the OHV overhead valve, like it says there on the slide, you're going to find out that, yeah, we have problems with, guys not adjusting the valves, not just on the L5P, but also on everything else. So like even the old LB7 guys, I tell them, if you're going to be doing injectors, you got the valve covers off, will you please adjust the valves too as well? So therefore, there's a valve lash adjustment that is needed. So very important to keep that in mind. So the oil capacity is 10 quarts. Well, 10 quarts. Well, the oil issue has been never ending, and I've been under fire, and boy, do I go ahead and shoot back too as well. And what I mean by that is that, when you got 10 quarts and you got all these trucks now have a huge tow capacity and tow rating along with payload capacity, you're really putting a lot of work on that engine oil. So as you look at today's diesel engine, constipated, congested, like I've said before, it is important to understand that oil change need to be changed. And what I mean by that, boy, that sounded wrong. What I mean by that is we need to keep an eye on the fact that should we shorten those oil change intervals, you know? And let me just sidebar on something real quick is that for some odd reason, you guys in the diesel society, and I'm in your group too, is like you seem to have accepted blow by. Every diesel engine back in the day had a specification for crankcase pressure. So in this case, is it okay to see some blow by? Yeah, but when we see a lot, that seems to be accepted, and hell no. So what has caused, premature, because we have trucks out there with 60, 70, 80, 90,000 miles, if not more, that are seen very early, excessive blow by that's enough to be recirculated and burnt, and that causes premature soot loading on the DPF. But the fact that there is excessive blow by, and it's not that much to say excessive nowadays, because that does affect the DPF. So you cannot use the old school mentality of the blow by you saw on an old engine back in the day, because of the fact that those engines did not have particulate filters. Now we got particulate filters, so you can't be messing around with this. So again, oil is a never-ending story that we're saying that you need to change the oil on these trucks. Therefore, you can see right here that the horsepower of the L5P started off at 445 horsepower, 910 foot-pounds of torque, right? And then you see the capacities up to 2020 of 43,500 pounds. Holy crapola, man. So therefore, yeah, that is something that is happening. Now let's not forget the L5P has its little brother cousin there. That's the L5D, which we see on these trucks, which you probably see badged with from International as well. So therefore, you might be dealing with slightly differences in them, quite a few, but the Denso common rail itself is basically the same, but in this case, there are a few differences as well. But let's not forget that these trucks are also out there as well. And you could see that their horsepower has been, again, reduced to 350 horsepower, 700 foot-pounds of torque. But your Silverado Sierra trucks, some of you know this already, are 445, 910, and it keeps climbing consistently. So therefore, that's what we see. Okay, so we got some tight time here, so I got to keep moving, guys. I'm going to answer your chats as we move along. So we have mentioned before about the electrical issue. Yeah, I'm here because this is a webinar and I'm here to sell you on training, but not just with me. Don't get me wrong. I'm not trying to be self-serving. But what I'm trying to tell you is, charging systems and electrical. But the one thing you got to understand is, do you all know how an alternator works? We recently did a class at the Alliant Power there in Windsor, Wisconsin. We did an electrical class. It was a small class, sadly, it was a sad class, but we were going over the operation of an alternator generator. Do we understand how it works and how the rectification process works, right? Because if you don't understand that, then you're going to have problems. Because when I hear guys, well, I put another alternator generator on the truck, and that still hasn't fixed it, or the light comes on, message comes on. Well, you don't know how to diagnose an alternator generator, really? So in this case, we should know how it works. So therefore, when we look at today's charging system, the alternator itself, hasn't changed much. Again, we call it generator because the output of it is DC. You're going to see that name. But look at the last sentence, like I've said before. And in this case, we see that if the generator has a field circuit failure, the generator defaults to an output voltage of what? 13.8 volts. So for those of you that want a diagnostic tip, one of the things we have seen before, especially with cheap rebuilt generator alternators, has been, can you have AC leakage from the diodes? Yes. So one of the things we've taught before in diagnostics, if this computer is acting silly or doing weird things like high idle, low idle, erratic shifting, sometimes it could be the source voltage. And what we told you to do was to unplug that generator alternator and see if that fixes the problem. Obviously, you can do an alternator ripple test to see if that's leaking as well. But like we said before, in previous L5Ps, we told you how the body control module is now in charge of actually determine when or how the output of that generator alternator works. So in this case, that's something you're going to see. So therefore, it monitors that. But the ECM is actually doing the task of controlling the field current and control of the regulator on that alternator generator. However, though the BCM is the one that's modulating that. In other words, he's actually monitoring that, not modulating, monitoring that. So with that said, that means that the BCM is placed. So the biggest headache now that I'm finding out in teaching classes has been the fact that we need to get up to speed on networks. Okay, where are you with networks? In this case, we look at a diagnostic link connector, and I know that a lot of you are not fluent on that diagnostic link connector. So where are you with it? I mean, if you know the basics, pin 16, power, pin 4 and 5, those are your grounds. We've been saying that for a long time. And then you also have your CAN networks. So therefore we need to understand CAN. And now you got local networks, which are better known as LIN networks from other people. So in this case, like it says on the bottom, this BCM, since he's in the loop and he's the decision maker of the output, you know, of the alternator generator, you're going to find out that he is actually, in charge. So therefore, he will actually require whatever charge we need to do. So therefore, why is this thing going freaky here? Excuse me a second. I don't know why it's throwing those lines up there, but we'll just skip it. All right. So therefore, that's what we see going on there. So please pay attention there that, we do have these things going on. So I don't know why it's throwing those lines, and I don't know why I did it. So I'm trying to erase it. Let's live with those yellow lines right now, but I'll try it because it's not allowing me to erase it. So for some odd reason, give me a second here. I'm trying to fix this here. I just love it when my computer goes freaky. All right, one more thing here. Let's see if we can get rid of it. No, it's not. So, all right. So with that, let's look with those yellow lines. I don't know why. I guess you're seeing them. I'm seeing them here on my screen. I can't take them off. I don't know why they're still there. All right. Since we're talking about networks, right? Since we're mentioning networks, I'll get to the battery current sensor back again, but let me go back to networks here. When you look at a network, for those of you not quite affluent with the network, the serial gateway module, which is the guy right in the center here, hopefully you can see my cursor, which is K56. And that's another thing we're seeing General Motors actually change. And what it is that now the serial gateway module is one of the main hubs for, again, your networks. I'm not going to go into detail in it, but in this case, we can see up here, we're going to find that we have our diagnostic link connector there. So here you can see, let's first find the ECM. Oh my God, where's the ECM? Well, the ECM is way up in the left corner right here over at K20. So in this case, now I'm going to zoom this. So therefore, hopefully we can do this. And you're going to find that K20 is located right there. And in this case, you're going to see the terminating resistor of 120 ohms. I know many of you are familiar with this, but again, we could see the end of one side and the beginning right here at 6 and 14. So therefore, we got our, excuse me, 8 and 14. We're going to see the, again, your start of your CAN network right there and the end of one side of the network. But if we move over to the other side, we're going to see a terminating resistor over here. So therefore, that's the end of that network. Now, why this is important to understand? Well, the reason why it's important to understand is because when you're looking at an whole network, one of the key tests you're going to do is the network alive and well, but you can do a continuity test of measuring, again, from 6 and 14 over to the 120 ohm resistor. So therefore, you're going to find something new. And what is the new thing? Let me skip to the next slide. Well, here you can see a local network right here, and you're going to see that there's the NOx sensor 2 right here. Now, this brings about a whole thing that nobody seems to be talking about that I happen to be looking at. I said, let's see, we got particulate matter sensors on these trucks, and we also have NOx sensors. You're going to find out that when you look at the NOx sensor itself, you're going to see the NOx sensor hardwired, no connection going to a NOx sensor module, which is part of the network. So therefore, if we compare that to old sensors back in the day, we had a reference voltage, we had a signal return, we had a ground, right? We can actually go ahead and scope the signal, look at an analog or a digital signal, but we got a problem nowadays. And the problem nowadays with NOx sensors and particulate matter sensors is that what can I test? In other words, how do I know that NOx sensor is reading correctly? It's not biased, as we call it. It's not a biased sensor. How do I know that the NOx sensor reading is accurate? And in this case, we're finding ourselves in a little bit of a pickle here. In other words, how do I know it's good or bad? Because it ain't like I could get a sample NOx in a box kind of thing and test the NOx sensor. No, there isn't to test the accuracy of it. And many of you have problem, and you're welcome to put it in the comment window, but many of you have probably caught yourself, just replacing the sensor, waving the white flag and saying, oh, I guess I got a problem here, right? So you replace it, and it's a 50-50 shot whether or not the NOx sensor was the problem. So the biggest one we're having with LML Duramaxes and L5P Duramaxes has been that the NOx sensor 1, not 2, NOx sensor 1, the one before the whole after treatment, has been an issue, saying NOx sensor 1 performance. And you're going to find in the service procedures, they're going to ask you to check your injection, blah, 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 check your intake, do all the basics. But then it comes down for them to tell you to evaluate where your NOx levels are at. So therefore, I knew when after treatment first came out back with the LML days that I said, we're going to look at a NOx sensor reading on the scan tool. What is a good NOx sensor reading? And the magic number that I knew we were going to come up with sooner or later was somewhere around 300 parts per million. So when I look at NOx sensor 1, I'm looking to see, while the truck is idling, where is my NOx sensor reading at? So therefore, it's like, well, gee, I got, I'm looking at it, the truck's items at operating temperature, everything seems to be okay, but I got NOx sensor issues or NOx issues. What is too high or too low? And the magic number I had to come up with, is 300 parts per million. So I've had to deal with issues with NOx sensor 1 performance. But that's just the reading on the NOx sensor, okay? So therefore, the thing is, what if electrically something is wrong? What can you do? The answer is nothing. You can check your ground and your battery power going to the module itself on the NOx sensor, but that's all you can do. It's all doing self-diagnostics. So more and more, we now see two NOx sensors. We see now the particulate matter sensor, and these sensors, again, are all part of a network, as you can see in the picture. So therefore, your job is A, how to analyze the network, but also B, how am I going to test these sensors? Because he's doing his own self-test. So let's step back for a minute. If you have a code on a General Motors product, I hope all of you are now using your DTC info. So when you look at DTC info, you can look at the status of the code. But you got to understand that you're going to use the code, as I'll show later on here. You got to use the code to tell you when it's being tested. How is it being tested? So therefore, those of you that have your scan tools, you need to make sure that you actually what? You look at DTC info in your scan tool menu. I don't know what scan tool brand you have, but in this case, you have to look at DTC info, go to specific DTC and type that code and look at the status of that code to see if it's tested. Because the reason why I'm saying this now is because a lot of guys cannot get rid of the code, but you probably have not met the conditions to test the code. So therefore, you got to read that code to see how it's actually doing, okay? So therefore, definitely got to pay attention to that there. So one, the reason why I'm showing these two slides right here is because once again, the network you see there, and two is your local networks that you see there coming off of knock sensor one. By the way, did you see the guy on the bottom right here that's controlling these two sides is knock sensor one. So knock sensor one is totally different than knock sensor two because again, he is in between two different networks right there that obviously can go eventually to the serial gateway module. But the bottom line is A, get acclimated with um, your your networks, but also get acclimated with how you're going to test these sensors and use your DTC info as you do that. Okay, very important for you to do that. So therefore, yes, I know you're going to tell me about mode 6, but I don't want to lose some of you just getting to mode 6. That's going to be another touchy subject there. But yeah, in the future, by the way, we're going to do a mode 6 thing. I saw a comment there about mode 6 testing too as well. But let's get one thing clear about mode 6 though. Mode 6 testing, unlike, you're dealing with networks here and you're going to, mode 6 kind of breaks down the code. And for those of you who don't know mode 6 real quickly, I know this gentleman just mentioned it, is the fact that there's a series of tests for one code. I get it. But the problem is you're wanting to know what part of that code is inhibiting the passing of that one code itself. So therefore, what I'm trying to say is, we're at the mercy of what the self-testing is going on inside because have you replaced, let me put it this way, have you replaced a sensor, right? Have you replaced a sensor and that took care of the derate condition? Yes, it has happened. I've done it's happened to me, happened to many of you. So therefore, that's telling you that, the sensor itself was at flawed because yeah, mode 6 will tell me what section looking at the counts, which where is it within that count for that given test. But the problem is it internally in the knock sensor or is it not internally in the knock sensor module? So that creates the challenge. So all right, we got to keep moving on here because we got a lot to discuss. So therefore, again, the question, like we says, where are we headed with these sensors and actuators? What are we going to do? I don't know why these yellow lines keep popping up. If you're seeing on your screen, I don't know why they're popping up. I'm trying to get rid. It won't let me erase them, so I don't know why it is. So sorry about that. But anyways, your Denso common rail system. Okay, yeah, as you know, the HP pump here that you see has been pumped. But like I said, when I see a premature pump failure, okay, changing the game now because this is a webinar. When we talk about premature pump failure, it kind of questions the cleanliness of the system and also the quality of fuel. Yes, we have seen fuel rail pressure be affected by the pump itself, but like we said already, don't fall into the novice trap. If you actually have low rail pressure issues, the truck won't start or drivability problem or losing pressure under load. Sometimes it's not the pump, it's actually what's going on with the injector. So there are injector return tests and so on that you need to do to see if we have a problem. But one thing you're going to find out about these Denso common rails is the fact that they have very minimal return, very low return, which Alliant Power has put out many bulletins regarding this issue. So therefore, yeah, you want to get some of those bulletins that Alliant Power has already provided. The one thing that really chaps my hide is the continuing bad habit of technicians not programming the injectors in. You might get away with it, but please note that that IQA code is there for a reason. So therefore, you need to program these injectors because again, it allows that ECM to ensure that all injectors are injecting the same quantity of fuel because can that also cause quantity and timing codes? It's far-fetched, you're right, but in this case, it is possible that can happen. So, as you look at Alliant Power, they have been selling you the injectors. There's some of you that have been testing these injectors, but obviously, the lines obviously need to be replaced. And, if you buy their kit, you're finding out that the passenger sides are no fun for the simple reason that, you got to get to that EGR cooler itself. But when we look at the common rail system here, okay, when we look at the common rail system here, you're going to find out that this common rail system here, okay, is totally different than what we've had in the past, like LMLs, which was a Bosch piezo common rail system. What is the biggest headache that I seem to be finding is let's not even hide behind it, is the connectors. You all see number 7 right there on the screen. Number 7 is your fuel rail pressure sensor, which is a 2-in-1 sensor. You probably have seen the bulletin. I hope you all know about it, where you're supposed to update that pigtail connector and you're supposed to use the dielectric gel. So for the most part, if you take that connector off, which is no fun to get to behind the alternator generator, If it's full of dielectric gel, that means somebody did the update most likely on it. So in this case, that is a never-ending story because it causes an array of different diagnostic trouble codes. So you got to make sure it has the update on it. So as I even talk about the connectors going towards the pump itself, and again, the connectors going to the rails, you're going to find out, yeah, they have a lot to be desired. So one thing that it definitely has changed, as you look even at the LM2 Duramax and you compare that with the L5P here, you're going to find out the connectors are becoming a problem. So therefore, corrosion, and it requires a new pigtail connector that can be the problem. So therefore, pay attention to that there. So with that said, please make sure that you understand that connectors are something you got to visually test, not test, excuse me, but visually check as you're working on these L5Ps. So what is the other different thing we're going to find? Well, number six. Number six is your indirect injector, which is using lift pump pressure. As you follow the flow, you're going to see that number six is the indirect injector. But what many of you are not understanding is the location of that indirect injector. If we compare that with the LML injector was located way upstream of the after treatment system, while the indirect injector on this is actually located downstream before the particulate filter. So you have the whole SCR system in the big front, and then you got the DPF DOC in the back. So with that said, you're going to be heating that DPF to run a regeneration, but unfortunately, it does not heat the SCR system. So if you have a heating problem where you're not reaching operating temperatures on the SCR side upstream of the after treatment, the running a regen will not help like it did with the LML. So therefore, that is a problem. Now, if you're not reaching full regeneration temperatures, please remember there is a flow test, there is a volume test you're supposed to do on that indirect injector on number six. So the good news is, since it's not like the LML, where it actually is using return fuel off the side of the injection pump, it is actually using filtered, fuel coming from the lift pump system. So that's what you're going to see. Now, on the scan tool, as I will show you here on the screen, you're going to find you can read your lift pump pressure there on the screen there for the lift pump. So you're going to find there is a sensor, which I believe is number 5. So number 5 is your lift pump pressure sensor, so you can see that lift pressure. So in this case, that still does not substitute what we've learned in the past with diesel, that do volume tests are still essential to do, yes. If in doubt, you can tap into the low pressure side of the system and you could still do a volume test. And we still use the traditional minimum number of somewhere of 1 liter for 30 seconds. So therefore, you might look at pressure. Pressure is one thing, but volume is another thing. So that still applies. So therefore, definitely check your volume to make sure you have good volume as well, especially for that intermittent stalling or loss of pressure code that you could have. Now, on the electrical side of things, the scary part is number 16 is our problem child, and that problem is the fuel pump driver control module. So this lift pump, as you can follow the lines for number 16, has been that fuel pump driver module. So therefore, on the scan tool, like I said before, you can enable the pump and you can look for what the pressure is, which is a minimum of 54 psi all the way up to 65 psi. So therefore, like we said before in common rail diagnostics has been, you start with the low pressure, then the high pressure, and then you also look at the return. If you got a low pressure code, you can't go after the high pressure side right away. You have to verify you got good volume and good operation and good pressure of the lift pump itself. So therefore, that's what you want to do. So we all understand that today's common rails tend to use that, which I call the pressure control valve and the volume control valve, because we're controlling volume of fuel on the pump, but then on the rail, which is number 9, we're actually controlling pressure. Now, I know that General Motors calls them FRPR1 and FRPR2. FRPR2, which is fuel pressure regulator, is, again, number 2 is number 9, while 1 is on the pump itself. It does have a traditional return system like we have seen, but in this case, let's first stick to the lift pump system here. Now, I do understand that you still got to do a test on the actual pressure control valve because that could actually have sediment. And believe it or not, I've always used that on many common rails to see if I do have contamination. Now, when I say contamination, don't jump the gun to talking about, in other words, metal in the system. Okay. No, what I'm talking about is contamination because of poor filtration. So therefore, filtration has been an issue there. So definitely want to pay attention to there is contamination because of poor filtration. So in this case, there is a spec from GM that they do offer you to go ahead and check that. But let me just jump a few slides here and let's get to the nitty gritty. Now, maybe I can clear these slides here. Give me a second here. All right. Oh, sorry, I'm trying. What I'm going to do here is add that. And then what I'm going to do here is go back to my, does it erase? It only erases what I got. Somebody has put that there. So one of you did it, I think. I don't know why you would have access to that, but you probably did. All right. All right. Well, here's my cursor. Well, when I zoom this up, all right, there you're going to see what we've been talking about, the lift pump itself. So therefore, if you're not acclimated with a three-phase pump, well, we've been using three-phase pumps for quite a bit now on other applications. So therefore, this is not a standard positive negative connection to a pump. This is a three-phase pump which can vary in speed, and it is monitored from the fuel pump driver control module. Well, one of the things that you're going to have to do electrically is you may have come to a point that you may have to test the pump itself. But before you get buck wild with this, please understand that there's got to be something from the ECM that tells a fuel pump driver module to here out of the K20 ECM. If we follow that wire all the way down, which is a green and gray wire, circuit 465, here you see it comes to this dash line box, which is again your fuel pump driver module. Excuse me. Now, that pin 18 is something that General Motors has been posting about testing with just something as frivolous as a test light. So you're going to just use a test light. But a bulb style test light, not an LED test light. And what they literally, this is not me talking, by the way, this is General Motors talking. And what they want you to do is go to, pin 18 right there on that connector. And what you're going to do is you're going to probe it and see if there's a constant signal. So if the truck has a inconsistent or stalling problem, it could be the fact that it loses the signal at pin 18, meaning that he has to see a consistent signal at pin 18 from the ECM to know to keep running the pump. Yes, I know you see the data communications, it is part of the loop, but no, it gets a straight wire signal going there to enable the pump itself. Now, if you do have the need to diagnose this circuit, you're going to see, by the way, here's the cavities right here of the connector of the fuel pump driver module. Again, this relates to DTC-P12A6 right there. So in this case, we got it going on here. So therefore, what I'm trying to say is you're going to, yes, probe pin 17 to see if you got a constant signal there. Yes, there is a key on where you're going to see a 30-second key on signal going there to prime the system up. But in this case, you're going to see if you're losing that signal. And that's important to understand there. So the question is, if the truck is losing power or a intermittent loss of rail pressure, you lose power, and it still runs, by the way, but it just loses power. One of the things you're going to verify initially is obviously check your signal going to pin 18. So the question begs, do we have a filtration volume problem or do we have an electrical problem going to the lift pump system? So nowadays, unlike what I've said before in L5P class, you're going to see on those three phases, is we're going to check those three phases once again, and now we can actually get. Now, here's the crappy part about it. Where is this located at? This fuel pump driver module. Well, it's located somewhere around underneath the spare tire. I haven't checked the 20 and later model, but I believe they're still located in the same place. But you're going to read an average voltage at pin 8, pin 9, and pin 24, which is somewhere around 6 to 6.5 volts. So therefore, that's an initial test, and that's telling you it's cycling on and off. And then you could read a frequency. So most of you that may be acclimated with your meters, you're going to find out you can read hertz of frequency, and you can also read the average voltage there. The problem is that we're trying to teach lab scopes is that the best way to test it is to actually use an amp clamp and use a amp clamp with a scope to see what's going on with amps, to see if we got an issue going on with the pump or again the driver in the fuel pump module. But for now, for those of you not scope savvy or have an amp clamp, with a scope, one of the things you may want to do at least is to check the voltage, which is an average voltage of 6.5, because it is a duty cycle, and you can also see the frequency of there that you're going to analyze there too. So therefore, very important to understand. Now, I do understand that you also have a relay right here, but this relay is for the what? This is for those trucks equipped with the secondary transfer pump. Those are trucks equipped with dual fuel tanks. So therefore, that does not go with the lift pump itself. So therefore, here you're going to see, again, information here for the lift pump itself. So therefore, there is K73, which is your main ignition main relay, which supplies power, as you can see, at cavity 17 going there. So yeah, you need to verify power and ground like in everything. Now, you should know this if you follow the diagnostic trouble code chart, guys. So therefore, very important to understand that. So, okay. All right. So therefore, yes, I try to get rid of it. It doesn't go, James, I try to get rid of it. It doesn't get rid of it. So go to the bottom of the screen, a pencil symbol will show up, and then go to the top of the screen and clear it to get rid of it. I'll try it, but I tried already, James. I tried. All right. So, all righty. Any questions there? So, well, I guess I'll answer questions at the end there. So I got a lot to cover here. I can get really in depth with this stuff, and I know I got limited amount of time. So you do have, okay, you do have, okay, your diagnostic trouble codes. Now, for those of you who've never attended my L5P class or any classes, I'm a big stickler about understanding what the manufacturer is trying to give you in service information. And I do understand that a code is a test. So when I said earlier about when you're dealing with these quantity, quality tests or any kind of codes, you need to know the conditions for running the code. You know, what is required, you know, what is needed to be there. So therefore, I'm not going to read this, but General Motors is always giving you the habit of telling you the description, the conditions for running the code, and conditions for setting the code, and then the action it does when the code does set. But then a lot of us don't understand, like at the bottom, you're going to see a type A code, a type B code. And you need to understand, know what kind of code you're dealing with. A code requires one failure and boom, the code sets, light comes on. Type B code requires two consecutive failures. So like I've stated before, one of the things that we've had to do was to, when we do a test drive, I'm going to somewhere, my test drives average about 8 to 10 miles. So what I do is I actually go ahead and drive the truck 8 miles, pull over the side of the road, turn everything off, open the door, wait a few minutes, turn the truck back on, and I could start another cycle. So therefore, it's not an official drive cycle, but it is a code test cycle that I'm trying to get that second code to run. That's why some of your diagnostic scan tools or your scan tools have what we call a pending code. And the pending code is a type B code where that first failure occurred and it's waiting for its second failure consecutively. So then at that point, it will go ahead and set the code to failure. In other words, you got an official code or hard code as we call it. So therefore, that's what you're going to see there. So for those of you who have never attended, you guys, I got some new faces here. Please note, you got to make it a habit to actually read up on these diagnostic trouble codes on how they're actually working, its description, its conditions for running, and so on. So therefore, don't just shoot it from the hip sometimes. And those of you that are gasoline guys, you're inferring a lot too. Be careful because that can bite you in the butt as well. So now, when you do different repairs, for example, if you're working on L5P, you're going to find out that in the one of the output menus that you have, depending what scan tool you're using, you're going to find out there's a lot of resets. Okay, there's a lot of resets. There's a fuel injection small quantity data reset. So therefore, please note, for example, here, and that's why I've decided to put this here. If you're working with the fuel rail pressure sensor, right, or the temperature sensor, fuel pressure sensor, in other words, the B310 and the 348, any kind of these sensors, it's telling you to do a reset, which is called the fuel injection small quantity data reset. So it is your job to do that reset, even for something as frivolous as a fuel rail pressure sensor or the pressure temperature sensor you find on the low pressure side. So it's important to understand that because that can cause intermittent issues or incorrect readings. So please make sure you do that because look at the note. This is from General Motors. It says failure to perform the procedure may result in poor system performance, DTCs being set, or customer dissatisfaction because of fuel economy. So therefore, that can happen as well. So obviously, I can only have time to show you one, but just understand there's many resets. I mean, I'll mention about glow plugs as well, which I've stated here. But in this case, glow plugs is another one as well that does require a learn procedure and a reset to be done as well. So therefore, we got to make sure we do that. Now, real quickly, the reason why I keep talking about glow plugs when I've done my L5P presentations in the past is because guys don't realize, even for a cold start, how hot these glow plugs are getting. You know, it's part of our one of our worksheets when we do the L5P class, and that is understanding that, you know, you are reaching a temperature of how much? You're going up to 2,192 degrees. And therefore, this system is cycling from 5.4 volts to 7.2 volts to 5.7 volts, and then back until 5.4 volts where we see 2,192. In other words, when I look at YouTube videos and I see these guys teaching you how to bench test a glow plug and you're putting battery voltage on it, holy cachito burrito, man, you're going to really cause some issues there. So in this case, please note that it is getting rather warm at 2,192, degrees. So therefore, please note, don't bench test these because again, these glow plugs are reaching some serious temperatures. So even when you replace them, because there's no such thing as reinstalling them. These are not reusable, as we stated before. So therefore, you're going to find out that you need to make sure that you actually do a glow plug learn as well. So, but it kind of irks me when I have to teach this because most of you should know that it is in the procedures if you follow the procedures themselves. So definitely want to look at that. All right. Turbocharger, the biggest tool that we find ourselves needing when we're changing or checking intake systems, you're going to find out is the smoke machine. Now, some of you are doing your soapy test, pressurizing using soaps. More power to you. If that works for you, that works for you. But, I am spoiled rotten using my high pressure smoke machine. Yes, we do have high pressure smoke machines out there that are available. Again, high pressure, not low pressure smoke machines, for the simple reason that we're trying to find boost leaks or intake leaks. I know some of you have called me and told me about leaks coming from the base of turbo. And if that leak is rather extensive, yeah, that is not going to be conducive to the flow and you're going to have a leak there as well. Yes, I understand that. Now, as you know, that turbo sits right in front of the diesel oxidation catalyst, which sits directly in back of it. Well, here's the deal though. When you are dealing with boost problems or issues, or somebody has modified or put an aftermarket tuner on it, such as not a delete tuner, but a performance tuner, that's the thing that we saw here, has been the fact that we see premature carbon accumulation on that DOC behind it. Okay. So therefore, we've been kind of in trouble because we're like, okay, how am I going to make sure that everything is good? First of all, make sure that it's learned. And this applies to all Duramaxes, by the way, all the way back to LLY. And in this case, have you verified that the learned is learned on the data PIDs of the screen? So obviously you're going to do one on an L5P, and like we've seen on other ones, you should perform a a learn procedure. So therefore, definitely want to do the learn. However, however though, that can be impeded by a premature loaded DPF or something going on the intake, such as your air filters. So therefore, definitely want to check your air filters and make sure you don't have a too much accumulation of DPF. Now, let me stop here for a second. If I were to ask you, hey, I want you to test that DPF, I want you to tell me if it's loaded. You all know we have a pressure differential sensor there. So what you're going to do is take a look at that pressure differential, the magic number we've been using right now, and believe me, it's a magic number. It's subject to change as we see different models, but I'm still sticking with 3 psi. So if you are seeing 3 psi at idle, even when you give it a little throttle in park or neutral, you got to make sure it does not exceed 3 psi, the differential pressure. But as you can see on the left right here, you're going to find that again, that you got your desoxidation exhaust number 9 right there behind the turbo. So why am I mentioning that? Well, the reason why I'm mentioning that, let me skip a few slides here, is the fact I'm going to skip ahead here. And the reason why I'm mentioning that is, where's my little slide here? Is because as you look at the back right here, you're going to see behind the turbo, you're going to see how fun it is to get to here, is the fact that every time you got to get to that oxidation catalyst back there, it's pretty buried back there. And I understand that. So therefore, you don't know if you have a restricted oxidation catalyst. So again, right behind there is that oxidation catalyst. And I get it. It's no fun to get to, but you're going to find that there is a NOx sensor there. So one of the things you're going to do is it's a Mickey Mouse thing, but it works. In other words, you're going to take the NOx sensor out, leave it plugged in, just hang it over to the side. And what you're going to do is fire up the truck and see what's going on now with performance. It's going to make a god-awful amount of noise. But in this case, you're trying to figure out if that oxidation catalyst is indeed carbon coated or it's got a lot of carbon formation. In other words, sooted. Okay, because that can happen, especially with those trucks that get poor maintenance and see a lot of idle time. Okay, they see a lot of idle time. So therefore, that could be your issue. So I would hate for you guys to try to figure out, I got no boost and I can't find no leaks, but maybe the issue is nothing to do with the fuel system, nothing to do with the turbo itself, but it's just the fact that that number 9 right there is your headache child that might be loaded. So, and you should have code set, but not all the time will you have it. So that's one thing you're going to see different with today's diesels is that you're going to see that a lot of these after treatment components are getting shoved up towards the engine because they're trying to take advantage of heat and try to do more passive regenerations as well. That's what they want to do. So definitely want to do that. So, all right. So with that said, definitely want to pay attention to that. So all righty, we're doing good. We're moving along. Got a lot, like I said, a lot to cover here. We're approaching the hour. Humidity sensor. Yes, there is a humidity reading you're going to get off the scan tool, but please note that's all part of the intake air temperature sensor too. So therefore, as you can see on the second paragraph, IAT sensor 2 produces a frequency signal based on the inlet air temperature, which is equal to the humidity present within the sensor bore. So this signal varies with the inlet air temperature and is displayed on the scan tool as Fahrenheit and hertz of frequency as the relative humidity. So therefore, that will eventually be displayed on your scan tool as a percentage, in other words, a percentage of humidity. So that's now inferred now with the use of the IAT sensor too. So therefore, if you're wondering where it's at or what it's doing, please note that that's all part of the inlet air temperature sensor too. Okay, very important to understand. All right. So as we do a scan, a very popular code that we see is a PO1DO. There you can see the scan. Injection timing advance, something I briefly mentioned at the beginning of this presentation. Obviously, you're going to find out also as you do a scan that there are various different other computers. So therefore, you're going to see a lot more if you're from the old school days. No, you're going to see a lot more processors reporting codes. And I wanted to show you that too as well, because I deal with advanced technicians, but also with technicians not so advanced. And you're going to see again a slew of different modules. There's that serial gateway module I mentioned earlier, right? So obviously your tire pressure monitor. So you're going to have a series of code along with your OBD2 codes as well. And then you got for those of you in California and other states, in Massachusetts, for example, you're going to look at your monitors as well. So, you got to see the big picture. So I'm happy to say that a lot of scan tools out there now are making you look at everything. You can do a total scan to see what's going on across the board there, because it is essential to know what is a consistent code that you're seeing. Which one do I address first? Well, it's the one that's actually set, but also that you may be seeing in multiple modules as well, because it's a tough call sometimes. And sometimes you have to deduct that by saying, okay, I see a fuel rail pressure code, but I also see a DPF issue. Does the DPF affect fuel rail pressure? Well, if the exhaust is very restricted, can it affect the rotation of the engine? The engine's lugging, running bad? Yeah, it could. So you got to infer a lot from that. So as we look at the codes at PO1DO, and I'm sorry once again about these yellow lines. I mean, Jim told me how to get rid of it, but I'm trying clear all dry. There we go. Thank you, Jim. That did work. That's why we love Jim. All right. All right. So now that we got rid of those lines, here you could see that we have the PO1DO. Let me get myself. The PO1DO, like we said already, as related to cylinder 3 injection timing advance. So you're going to find that you may confront this code itself. Now, please note, when you look at these codes, including the timing and the injection timing, injection quantity, you got to really understand, once again, the flow issue from the intake, like I said, to the exhaust itself. So when we look at, first of all, this PO1DO, the most important thing you need to make sure is it happening, right? And in this case, it has to see a decel condition. So like I mentioned in previous L5P classes, I have my route here in North Las Vegas where I get on the I-15 off of Craig and I accelerate, get it up to 70 miles an hour. And as I'm exiting, I got this long decel on Cheyenne Avenue and I can actually duplicate this. So I got my track here, or my little route that I do to actually run this code. Now you're probably asking yourself, okay, Tony, but how do I know it ran the code? That's why you lose that specific DTC under DTC info. So in this case, you're going to click on DTC info, go to specific DTC, type in the PO1DO, and you're going to see if it ran the code or not during that drive cycle. And that's where you ensure the problem is there or not. because that's the problem a lot of you are doing. You're clearing the code, but it's still there. So even though you haven't run a deceleration, so therefore you may want to verify, before you go buck wild testing everything, you may want to go ahead and run a decel event. So have we fixed this code by simply running a regeneration? The answer is yes. Have we fixed this code by replacing the air filter? The answer is yes. But then have we also fixed this code by looking at map sensor and looking at mass airflow sensor? And the answer is yes as well. So therefore, understand, like it says on the bottom paragraph, that when you're addressing this code, the control module K20 adjusts the injection timing for each injector based on changes in rotational speed on the crankshaft. So the control module stores the injector timing value. So therefore, what you're going to do again is, once again, conditions for running the code. So there it is. You got to make sure you achieve all this 1200 RPM to 2100 RPM on a decel event. And it's got to be longer than how many seconds? 20 seconds the decel event. So here it is, all in the service manual of how to run this code. So at that point, again, it is a type B code. Okay, so what did we learn about type B codes? Well, a type B code has to occur what? Twice. But if you have a scan tool that can give you pending, you're going to find it under pending. So therefore, you're going to say, oh, it failed once. But then if you have to test it again to make it official, you're going to have to do how many decel events? 2. Everybody following me? I hope you're following me. Because type B requires how many events to become an official code? 2. But if it fails once, it's only pending. Okay, so therefore, that PO1 diode requires 2 events. So now, obviously, when you're testing this code, this is why, again, I love that guys don't want to read the code, because here's an information. Do not go after this code if there are other related codes to these components, such as your crank sensor, your map sensor, your EGR valve, and your fuel system issues too as well. So, got to make sure to do that. And like I mentioned already, it is a good idea to make sure that fuel is not contaminated. I've been recommending this company for a long time that actually is sticks that actually will test for traces of DEF fluid, And if it's a fleet truck, you don't know if the driver put a little bit of gasoline in it, maybe did an oops and just maybe added half a gallon to the tank or a gallon, whatever. That could be a problem too. So don't take for granted that you think that the fuel is in good quality. It could be contaminated with DEF fluid or gasoline. Or maybe somebody put a fuel additive that just is not conducive to the system as well. I mean, there's so many variables. I mean, that could be issues. So therefore, from keeping it basic to keeping it more advanced, again, it is a good idea to make sure your fuel is good quality or decent quality. So highly recommend using those sticks to actually, or strips to actually test to see that you're not contaminated with gasoline, you're not contaminated with DEF fluid as well. That can also be a headache. Now you're going to find out in the service procedures, whoa, this came out too bright, but in this case is compression, okay? Let's not forget about compression, especially if the truck has had a tuner. My God, that's the ones you got to watch out for. But look at the spec that General Motors has written there for compression. It is 300 PSI. Again, no great variance of greater than 50 PSI. So therefore, they're telling you to, again, make sure you test that compression, make sure it builds up quickly. So therefore, you're trying to find out if you got a piston rings and valves leaking. Now, some of you are big time into using your scopes and doing a relative compression test. I get it. But we like to know, from my point of view, we like to know if the problem is lower end or top end, if you know what I'm saying. In other words, valve train, or is it in the piston or the block itself? So sometimes we need to address that, which a relative compression. Now, Jim Wilson's already introduced me to pulse testing, but we're going to work on that. But in this case, that's something we want to look at too as well, but that's coming. So let's apply this. Okay, we've been talking about a lot of subsystems. Let's apply it. So I found this and I thought I'd share with you. This guy just bought a 2019 Silverado with an L5P. Obviously, it looks like he bought it used at 28,000 miles. No sooner than 15 minutes driving off the lot. I was laughing as I go, dude, just right off the lot. Check engine light came on. I ran the codes and popped 3 codes: the PO1CD, PO1D2, PO1D4. These come back as fuel management codes. I have looked pretty hard, but I haven't seen much on those codes. Truck has only 28,000 miles. Now, what are those codes? Well, those codes are what? The cylinder 2 injection timing retarded, right, for 2, 4, and 5. So the control module learns the injector time performance when the following conditions are met. So therefore, he must have done a deceleration event, or the dealership might have cleared the code and it just came right back. I don't know. So therefore, again, it's all based on crankshaft rotational speed. So you can look at balancing rates. I get it. But the problem is that, you don't know what's going on more finite. In other words, what is he finding under a load? Because if you think about it, when we're looking at balancing rates, the vehicle's not under load. So therefore, there's a big difference there. So obviously, there's conditions for running the code. We've been talking about that already. And he's telling you that again, it's out of range. Do they tell us how much out of range is? Nope. So that's what sucks about it. And that's what we have to quickly understand what is going on. Now, those of you that have your common rail test bench in your shops, we have found out, I'm not going to name any names, but we have found out that some of them have failed. In other words, what I'm saying is it has passed it on the test bench, but then you put it back on the truck, boom, it sets that code again. So it could be injector, really cannot be injector. So what is it I'm teaching you now? We caught this by accident, and even one of my techs, that God love him, he was a good guy too. We caught it by accident. And it was that as we were scrolling through the data menu, we looked at misfires. As you know, you got misfires on these L5Ps. You can look at misfire. So do me a favor. If you're dealing with these kind of codes, you may want to look at your misfire counters, because if you look at misfires, most of the time it's counting, it's checking for misfire, or reads zero most of the time. There's no issues. But in this case, if you got an issue, you're going to find that it might intermittently show a one. In other words, might account. So unfortunately, I didn't record it. I should have recorded it, but I'm waiting for another one so I can record that. But in this case, look at your misfire data menus in your scan. So I don't know what brand you have. But in this case, take a look at misfire when you're dealing with codes and just let her idle and just watch it to see if there's anything going on that it catches misfire, which can help you catch that injector that's giving you that headache. So that's something new that we haven't discussed before, is look at your misfire counters when you're looking at these quantity timing tests. Now, I know what you're thinking. Well, I should be able to feel a misfire. No, they are so small that only that crankshaft and the relative rotation at angular velocity, he's catching it. But in many cases, you won't even feel it. The truck is just purring like a kitten there idling. So therefore, please be aware of that, is to look at your misfires there too as well. So when you're dealing with all of this, they tell you that there's no other, they ask you to make sure there's no other issues going on these subsystems, right? And then they're going to tell you to make sure that compression is good, because compression can be an issue. Well, now some of you may have cheated like I do. If I can do it, I do it. I'll take the inner fenders off. I'll try to do an infrared with my infrared gun. I'll try to see if all the cylinders are equally firing using temperature. But in this case, at that point, they're telling you that if everything else is okay, compression is okay, then it's the injector. But it's not really conducive, this steps here, because of the fact that if I'm going to do a compression test, I got to remove the glow plugs. And if I remove the glow plugs, that means I got to replace the glow plugs, right? So in this case, we tried, that's where I understand a lot of you like to use the relative compression testing using the scopes. That's where it shines very well. However, you know, pulse testing is another thing we're going to be talking about later on. So in this case, definitely want to look at that they've been doing in the gasoline arena already. So, because what happens? Some people get to the point where they replace the injector and that code is still there. Well, what they don't mention is that, one of the key guys that has been the problem, because the first time I ever got my first ever L5P coming in a few years ago was, I was on the phone with a tech and he said, "Hey, Tony, what are you up to?" And I said, "Well, I'm working on L5P and I got my first injector quantity code." And he goes, "Tony, look at the map sensor." He goes, could be most likely maps. I pulled the map sensor and it's coated with carbon to the point it wasn't even, I couldn't clean it. So I just replaced it. So therefore, the map sensor was heavily coded. As soon as I installed it, cleared all the codes out, reset everything. Next thing you know, the code went away. So in this case, it was the load sensing sensor. And who's the load sensing sensor? Is the map sensor. So like any sensor, the map sensor is prone to becoming clogged on these and gunk. So therefore, some of you in the aftermarket already know about the spacer different companies are selling. There's some on eBay, other companies are selling, where they're putting a spacer over the map sensor to try to alleviate that carbon coating or soot accumulation on that map sensor itself. So be aware of that. So therefore, when a map sensor fails, inaccurate vacuum or air pressure readings are sent to the computer, which then affects the amount of fuel being delivered and set false codes as well. So therefore, that's what you're going to see. Okay. So therefore, what are symptoms of map sensor failures? Obviously, you should know how to diagnose it and read it, but it can cause those misfires too as well. Again, running too much fuel strategy or too little fuel strategy. Obviously, check engine light, lack of power, and overall poor performance, rough idling, engine stalling, hesitation, etc. So that's what we would have to check for that customer that has those codes, because what I would need to know is how well it's running on that case scenario that I sent you. So I get it once again that in the past, you have looked at injector command as well as balancing rates. You're looking at that. So balancing rates can still be used to see which injectors really overfueling and underfueling. Because remember, this balancing rates that we've been using in Duramax has been telling us if we're overfueling or underfueling. It's a command. It's not a fuel trim. Okay, it is a command. It is what he is doing to add or subtract. Plus value, right? In this case, meant to add more fuel. Subtract fuel mean to, again, you're overfueling, so you're trying to back off on that fuel. But let's get one thing clear. Every time that, I've been a big user of fuel cleaners. Okay, I've been using fuel cleaners for a long time. And one of the things I've been telling guys is, we use aggressive fuel cleaners. And in this case, that fuel cleaner has been good to clean those injectors. And yes, it has worked. And believe me, I'm not a snake oil kind of guy, but in this case, that has attributed. So when we talk about the quantity codes, using the FSA adaptation that some of you need to learn that we teach in our classes, has been that it's something that the computer does to know what the amount of fuel that's being delivered. But the thing is, what you're going to find out as they talk about FSA is now that NOx sensor 1 is actually now a player. So here's the deal. The classic one I've been teaching for years now has been an LML that gave me headaches. I had an LML Duramax that I now apply to an L5P, and some of you may have heard the story, and I apologize, but it's okay. Um, where I had a NOx sensor 1 performance code. And the thing is, I could not figure out back in the day why I was getting NOx sensor 1. For everything was checking out. I mean, I could tell you all the details, but everything was good. And came to the point like, Jesus Christ, I don't want to replace this NOx sensor. And I'm looking at the parts per million on the scan tool. And I'm saying to myself, okay, what is too much, too little? Now that I know, I was reading in excess of 450 to 600. It kept changing, but it was averaging between 400 to 600 parts per million, which now I know that is excessive NOx. And in this case, I said, yeah, we're dealing high NOx. But then I'm trying to fix this truck because the truck runs great, but it kept setting that NOx sensor 1 performance. Finally, my guys looked at me and they're like, Tony, just replace the sensor. I go, it's not the sensor, but they're like, just, all right, fine, wave the white flag and replace the sensor. Oh, obviously replace the sensor. And within minutes of it getting warmed up, guess what happened? Boom, there comes that code right back, right? NOx sensor 1 performance. So in this case, finally went back and forth. And I said, okay, I understand how NOx works. NOx is generated by high heat in the combustion chamber. So therefore, what causes high heat in a diesel? Excessive fueling. So I'm like, okay, it could be the injector that's leaking, but I see in the balancing rates that it looks pretty good. So therefore, yeah, I'm not over the plus or minus 5 or 4, whatever it is. So therefore, I'm nodding my head. I go, wait a minute. So I go back to the scan tool and I reset the fuel adaptive parameters. Yes, there is a reset. Like I said earlier, there's resets. So I reset the adaptive parameter. And then at that point, within clearing the code, guess what? The code never comes back. So in other words, it was the fuel adaptation that was doing that, the learned adaptation that it was doing. So therefore, that caused it to happen. So therefore, be aware of that when you're dealing with these quantity and timing codes as well, that you can reset it. There's no sin in doing that. But do understand that anytime you do a reset and it does do the repair, it is wise for you to tell the customer that there may be a change in fuel economy until it learns it better. So therefore, please, if you especially got that customer is really anal with fuel economy, you got to make sure they take a look at that. All right. So obviously the diagnostic trouble codes are telling you a whole heck of that field adaptation. And again, airflow, like I've said already, will affect the readings causing these codes to set, because the NOx sensor can be the guy that's doing it as well, saying that you're generating NOx. In other words, if I want to know if an injection system is overfueling, it's going to cause more heat, cause higher levels of NOx. What are you going to do? Look at NOx sensor 1 and see if it's, what was that magic number that I said earlier? No more than how much? 300 parts per million. So therefore, definitely want to do that. But in this case, make sure you have that. So your Snap-on Ultra, you're saying that scan tool did not have fuel inject small quantity data reset. Yeah, it's supposed to have them. My excuse me, my Snap-on Zeus does have it. So therefore, you may want to get on your Snap-on, but maybe you have an update available for your Scan 2 as well. So why don't you check that as well, sir? So there you go. So therefore, an aggressive cleaner, Alliant Power sells one. I'm a big BG245 guy too as well. So in this case, you want to use a cleaner. So therefore, definitely want to Standardine sells one as well. So therefore, definitely want to run cleaners in these fuel systems, because for those of you that know me with the BG245, for example, and some of you have used the Alliant Power, you told me the same thing. You want to clean the system. That's why today's fuel systems require cleaning periodically. There's aftermarket companies selling you cleaning systems. And guess what? I hate to say it, but they work, because the nozzles can actually get dirty. So therefore, they're not spraying the seven spray pattern, whatever pattern it is. And we have had success with using aggressive cleaners. Like, with me with BG245, I actually do use in a very aggressive formula with the fuel to try to clean it out. And I've had success with it as well. That can cause also injection issues. So definitely want to pay attention to that. Let's not forget the mass airflow sensor. The mass airflow sensor, like I said already, that's another key player there. Its ranges between 5 to 40 grams per second. It is a wise idea for you to take, readings of those normally trucks, how they look at what they're at normally. But always remember, though, certain aftermarket filters going to change that reading. So be aware of that. All right, after treatment. As you can see, if you don't know after treatment, please take an after treatment class. I mean, we have an after treatment presentation on my website, powertraintraining.com. But in other words, learn after treatment, please. And learn it, don't infer it. So therefore, number 18 is that guy that's after the turbo. Okay, that is your diesel oxidation catalyst, while number 17 is your DEF fluid or reductant injector right there, number 17. So that must mean that number 16 is your NOx reducing catalyst. So therefore, we see a NOx sensor at number 15. So number 15 before number 18 and number 15 after 16. In other words, NOx sensor 1, NOx sensor 2. So what's number 12 over there? Well, number 12, as you can see right there, is your particulate matter sensor. So particulate matter sensor is being used there. Now, if you haven't had a class on particulate matter sensor, it takes samples. It samples, it cleans itself, regenerates itself, then it takes a sample, regenerates itself, takes a sample. So it's not consistently reading the amount of particulates that's in the system. It's sampling, okay? So number 10, that's why I told you running a regeneration, that's your indirect injector, meaning that number 14 is another oxidation catalyst, and number 13 is your diesel particulate filter with 11 as your differential pressure sensor. So in this case, please understand that when you run a regeneration, you are not heating anything in the SCR. So many times the trucks that do a lot of idle time, or like tow trucks that we have here that don't see a lot of highway time, they just do local stuff. You got to understand that that SCR needs to achieve a certain temperature for it to do the ammonia conversion and break up the NOx, right? So therefore, you need to get the truck really hot. So people ask me, well, how do I get it hot? I go, I hate to tell you this, but go drive the holy bejesus out of this truck. In other words, beat the hell out of this truck, because that's the only way you're going to get her hot. In many cases, that does help, because ever since I taught after treatment 101 since day one was, what is the number one issue with these is they're not getting hot. So we got to get them nice and hot, nice and warm. On an LML, guess what? I can run a regeneration. But on a L5P, as you can see here, running regeneration does not heat the SCR assembly. So therefore, I'm sorry, a regeneration is not going to bail you out of this one. So therefore, that's the problem with it. So yeah, like Jim says, drive it like you stole it. So definitely. So therefore, yeah, this is not an after treatment class, but get to know the after treatment, which we teach in our classes as well, because I get frustrated. A lot of guys don't understand. So yeah, number 7, by the way, in case you did not know, that is a DEF quality sensor. It's testing the quality of the DEF now. That's new. So therefore, we're testing DEF. So therefore, when you look at the whole after treatment, it is a 4-stage process. You got a DOC right behind the turbo. You got an SCR stage. Then you got it with the NOx brick, as we call it, or NOx reducing catalyst. Then we got our another DOC, and then we got our DPF. So hopefully you saw that here on that slide and understanding the L5P structure and how it works, So Always remember something as we talk about it right here, and we're talking about it here. Please note that the health of an after treatment is based on the quality of the exhaust. I make this joke, what is that? I put myself on that number 18's position, what is the quality of that exhaust? Is it clean exhaust, not heavily, no oils, no heavily soot? That's going to bombard and create premature ash accumulation in that DPF eventually, So blow by is your biggest enemy. So I know I've said this many times in other presentations, and I will say it again probably tomorrow with PowerStroke 6.7, is that you got to understand that the number one enemy of particulate filter is blow by gas. You got excessive blow by gas, you're going to just mess up this whole system, because we get premature soot accumulation, which eventually will cause premature soot loading as well. So there's a better view. I should have moved this slide earlier, but there's that DOC that I was talking about behind that turbo. And there's that bungle for that NOx sensor right there where I told you can remove it to see if you get some power back, because this can actually be loaded, which we already have found the case to be, as you can see right there. So be aware of that. Here's a side view of that. There you could see the NOx sensor located there on the side right there. So yeah, that could be your headache child causing issues there. So now let's get one thing clear here. I know a lot of you are dealing with deleted trucks. My headache with dealing with deleted trucks since I went back east back in April, May, I was gone for 5 weeks and I got to work on a lot of deleted trucks. And oh my God, it's like delete programs. The problem I'm having with them is that whoever's doing the delete program is shutting down all diagnostics. So you can literally have a truck with a little loss of rail pressure, something's gone wrong, and there's no code set. So yeah, if you're going to delete a program, I can't tell you what to do. I'm not the law, but I am telling you, will you quit turning off certain diagnostics because we need them when we're trying to troubleshoot them, especially when they're deleted. So that becomes a problem. So always remember, though, I wanted to sidebar this on the after treatment, is that there is a controller for the after treatment that is talking to the network. So that's a separate control. And if you look at this picture, under carriage picture, you're going to see where they put it. And oh my God, it's located, way in under carriage there. It's exposed to the elements. So therefore, please note that the SCR system has its own separate controller, or SCR module, if you want to call it that. And then, like I mentioned already, there is the PM sensor, the particulate matter sensor, like it says at the bottom. It is a two electrodes, and believe it or not, it is taking a sample of that exhaust. If it has enough particulates or soot, it is actually going to create a bridge between two electrodes, become conductive, because believe it or not, particulates are actually, they have a conductive property. And as there's enough of it, it's going to become conductive. And then at that point, it's going to give you a reading of what that particulate matter is. Now, those of you that are going to be watching the recording of this, you can pause this and you're welcome to read on its whole operation. So remember, those of you who've been watching or are going to watch the recording, you can pause and read all about this, because obviously I don't have enough time to cover all that. But just know, like I said earlier, there's a standby mode, and then there's the measurement mode where it's actually measuring, and then it's got to have some type of regeneration mode to actually clean itself out. So that's the third mode there, so which I didn't put up there. Now, we did talk about that indirect injector. There it is right there. Please note that in this case, what is the flow that it's supposed to have? Is that no greater than how much? Well, it says there if any measurement is less than 27, so therefore it says no greater than 37. So therefore, what is the range? 27 milliliters to 37 milliliters coming out of that indirect injector if you ever want to test it. Because if you don't have enough fuel coming out of it, it's going to actually not heat enough to run a regeneration event. So please note, it is giving you a spec for that indirect injector. So, all right. So yeah, when you look at the scan tool, there's your display codes, there's your DTC display, right? You can click on that, and that's where you see, again, the codes themselves. But then I could also kick back and I can also look at specific DTC. So I guess what I want you to do is when you get back to your tools, and the one guy already mentioned already, is what is available for your codes. Do you have specific, there's my DTC status right there too as well. And I'm looking at freeze frame right there. So in this case, you do have an array of different things you can test. So if you're looking, I didn't take a reading on that. Let me backtrack it here for a second. Right there, you're going to notice that there is DTC status. That's where you find out the status of the code. That's where you click on. So you want to make sure you have that. If not, you may want to be looking either at an update on your scan tool or probably another scan tool. And don't complain to me about scan tools. I know about scan tools because of the fact that I got a whole bunch of them, you know. So therefore, yes, Tony's wallet gets slim sometimes because of the fact of all the resets that's out there. So there's different resets out there. Obviously, this is a 17 model. You're going to find a lot more under module setup and on the outputs. Look at all everything that you have there. So definitely look to see if you have all the appropriate resets, and you're going to know. That's why I recorded this for to make you aware of all of them that are out there. There's a small injection quantity data reset that I mentioned there. So you'll notice here you can see, sir, there's the my this is a Varus actually, not the Zeus. This is a Varus right here. So even the Varus has that too as well. So that's why I tend not to use the GM Global scan tool because A, it takes forever to get that thing fired up. But this, Snap-on's a lot quicker, but I'm not endorsing Snap-on. I'm just saying this is what we're using. Actually playing now with the gel test too as well. So I'll be doing some videos later on with the gel test as well too. So we're seeing if they have all of this, and they're taking input from me on that. So that's kind of nice. So, all right. When it comes to scan data, we mentioned about lift pump pressure. Obviously, you're going to see a new thing. And the reason why I'm showing you this is because you're going to find here that nowadays he's telling you on data screens, different data streams or PIDs, the status of it. For example, we understand that if you got a open circuit on the fuel regulator one, that's a code. It will set a code for that. So instead of telling you if the code is set or not, he's going to be telling you right on the screen if it's okay. In other words, he's continuously testing these circuits for low voltage, high voltage opens, and that's the newest thing you're going to see on the screen now, is that it's telling you the status of those circuits. So therefore, he's doing a lot of your homework. Okay. So as you scroll through the list, it's even telling you the status of the three-phase circuits on the lift pumps right there. So he's doing his own testing there to see if it's open shorted as well as you go down the list. So again, if you're new to L5P, you need to get really acclimated with the new, actually it's not new anymore, it's been around since 2017 because it's changed since LMLs. So therefore, you're going to see a lot more information available for you to view to understand what's going on. You can see the status of various different circuits there. So there you go. Okay. So definitely want to pay attention to that. So, all right. Very important when you're dealing with these. So that's about drawing me to a close here. I'm about 5 minutes. How did we do? Let's see. Let's look at some of this. I had a problem with a clean to drivable status on the highway finish. Yeah, I understand that, Mr. Rico. Quick clean works for you. Snap-on Ultra. Yeah, you need to get that updated or may need another one. Therefore, need to go to the bottom screen. Yeah, you tell me to clean that. So therefore, yeah, so just dealing with all your questions right here. Whoa, this is a long question. The vehicle check engine came on the reverse drive cycle, returned, and Matthew did that. So therefore, there you go. Okay, any other questions? I think I addressed almost everybody's issue. Matthew said a turbo unique is issue. We have had done previous injector pigtail repair injector knock sensor to complete the repair. So, yep, I got that. Amen on the blow by. Yes, thank you for replying on that for the blow by. So, all right. So, all right. So it looks like did we help you out? I mean, did some of the information help? Let's get some input from you. I'd like to hear from you there. So therefore, is there a list of go, no go for what is needed to regen? To be honest with you, if the truck seems to be running fine, you may want to do a regen regardless. But like I said, look at your differential pressure and see if it's greater than 3 psi. That is your telltale if you're getting loaded. Is 3 psi. And believe me, that's not my number, by the way. That came from GM service information. So therefore, that's pretty cool there. So very funny, Corey. Very funny. Very funny. I saw your comment there, buddy. Anyways, good comments, good repairs. So therefore, very good. All right. Any others? Let's see. I'm scrolling down the list. What is the estimated time of regen on these trucks? Average, most of them are under an hour. Put it to you that way. It's rare that I go over an hour. So some of them, if they're cleaning up quickly, they'll stop within 30 minutes sometimes. So therefore, he's monitoring that. But again, differential pressure is no more than 3. What is normal? Normal that I see sometimes is somewhere around 0.5 to 1, 1.2. So therefore, that's what I usually see. But that's telling you again if you're loaded. But don't be afraid to run a regeneration, guys, because I'm at the opinion, even if the truck comes in for service such as an oil change, and I look at differential pressure and it's staring at me at 1.5, 2 pounds, I'm going to run a regen anyways because I'm trying to reduce any regens over the road. And then I'll change the oil. So don't be afraid to sell that regeneration to the customer because you're doing them a favor by allowing that to be cleaned up, So therefore it leaves with a clean DPF along with good engine oil. And last but not least, remember the engine oil. I said that at the beginning. You got to look at engine oil. If you're doing those 10,000 mile change intervals, that engine isn't going to live long. Not at all. So in this case, you need to be doing those oil change intervals. I'm a big advocate between, if it sees a lot of stop and go, 3,000. And I know some of you are going to panic, going, "What the hell, Tony?" I know, I get it, but and if it does some good highway time, 4 to 5,000 mile change intervals. So definitely, if you don't do it, don't do it. I'm saying it's, really want to do that. So, where do I get the test strips? Just do a search, but it's Diesel. What's the name of the company? Diesel Max? Diesel, not Max, Diesel Max. Oh God, I forgot the name of the company. I have it saved on my files. Tell you what, send me an email and I'll send you the link to their website. I have it saved. I'm sorry I don't have it with me, but definitely I'll send you that. So Reiko Marks, yeah, send it to me. It's T Salas at dieseltg.com. That's my website. T Salas. So therefore I'll type it in right here so you guys can have it. By the way, yeah, if you want to send me any emails, is T Salas at, where's my at? I don't have my glasses on. I had to take because I get reflection off the monitor. At dieseltg.com. Yeah, there we go. So therefore, it's T Salas and Dieselcraft. Thank you, Kyle. That's who it is. Dieselcraft. Yes. Dieselcraft is the company. Thank you. Why are the glow plugs one-time use? Because they're ceramic. They get distorted. So therefore, for that high heat, they got to use ceramics. So therefore, yeah, that's why they're one-time use. So don't reuse them. Alrighty, definitely want to do that. Should I do injector reset only when I change an injector or when the map sensor? Let me put it this way: anytime you want. The answer is anytime you want or you suspect. There have been times that I've had to reset everything. So therefore, I had to reset it many times. So don't be afraid to reset it because when you reset, you're just resetting any learned memory. So therefore, it doesn't hurt it at all, as if the truck just left the assembly line. Look at it that way. So, and Corey, I put the email. Look in the chat. Scroll up on the chat. You'll see my email right there. Very good. I like you guys having questions. I appreciate that. So therefore, yeah, visit us definitely at powertraintraining.com. We have a training coming up with Align Power at Zimmy's Diesel in Lebanon, PA. I do have a diesel master course. And by the way, those of you that know about my diesel master course, please note I've updated. I've revamped the whole damn thing starting in October 9th. I got a 5-day class on the big three, but it includes electrical training and diagnostics. And I've been going hard making all the worksheets and stuff. I really have been working hard at that. So therefore, that has been a challenge. But definitely visit us at Powertrain Training. Definitely want to do that. So, all right. Any issues with renewable diesel? Um, you're talking about bio? If you're talking about bio, my question is it certified bio? Because one thing I've learned working with different guys that do bio is if I don't hear the word methanol, that's telling me they're not using certified. Because one of the key ingredients you need to put in biodiesel, believe it or not, is methanol. So therefore, that's another thing that I've learned. So therefore, yeah, I know about your 99% bio crap in California. That can be an issue. But the way I fight back with that is it certified bio? Because there is a certification out there for biodiesel. So yeah, bio can be a headache. So therefore, be aware of that. So very good. Any other comments? And by the way, before I finish up here, we'd like to thank Alliant Power for sponsoring this. We want to thank these guys. And those of you that are watching the recording, thank you for watching. You can always email for any questions as well. And we got some last minute questions. Does it skip? Let's see, what else are we having here? How often do you recommend performing a fuel system clean? Minimum, depending on the fuel and what the filters, everything. It all depends how much filter's been done because you're going to find out General Motors on their Duramaxes, they keep insisting on using just one filter, and they're still using one filter. And in this case, because I'm a big advocate of changing that oil every other oil change. So therefore, because of the quality of fuel that we have, because you got to understand we're on the border with Utah, and Utah fuel is not the greatest that we have found. So I would say at least minimum every 30 to 50,000 miles. So definitely somewhere around there, I would say. You got a thumping sound on the 2020 L5P. Yeah, you're gonna have to elaborate more on the thumping sound. So I'm gonna need, why don't you email me on that one, Anthony, and I'll try to help you out with it. And does it skip when you just crank it over with FICM disable and without? Whoa, Kyle. Boy, you threw me a curveball here. Let me go back to Kyle, what he's trying to say as I'm finishing up. Does it skip when you just crank it over with FICM and without letting it start if you have compression issue or valve adjustment issue? I'm lost what you're trying to say here. So I guess you guys, unfortunately, since I'm on a time issue, you're gonna have to email me, and I will definitely try to respond to those questions. So I'm not seeing email. Once again, it's let me type it in again. Email is tsalas@dieseltg. And by the way, if you haven't visited us at Diesel TG, Diesel, it's a forum. So therefore, you're welcome to join us there. It's free. Just click on forums and you can join free of charge. And in this case, that's the Diesel TG website, which I also host as well, where guys can post. It's like a blog where guys post their issues. So there's my tsalas at dieseltg.com right there, guys. So tomorrow is Power Stroke 6-7, which is also sponsored by Alliant Power. So we're going to do that tomorrow with Power Stroke 6-7. So therefore, if you want to join us tomorrow, definitely sign up for that if you haven't. And we will see you tomorrow. Any last minute questions? I mean, have you learned something? I lost 20 people already logged off probably because they have to go back to work. But sorry about the yellow markings, but we'll get rid of those yellow markings next time. Now that Jim told me how to get rid of them, so definitely get rid of them. So thank you, thank you, thank you. With that, I say goodbye. I thank the Land Power, and we will see some of you tomorrow. God bless.